All right, here we go. Unit 4, Lesson 2, adding and subtracting rational expressions, which remember, again, is just a fancy word here for fractions. So yesterday we worked on multiplying and dividing rational expressions. We learned that you just multiply straight across the top, multiply straight across the bottom, and that factoring and canceling can reduce your workload a lot. The only additional thing we learned last time was that when you divide fractions, remember that means to flip the second fraction and to multiply it. Now it might be interesting that we're doing adding and subtracting on day 2. Usually we think of those as easier, but in terms of rational expressions, adding and subtracting is actually harder. Because remember, you can only add fractions that have a common denominator. Your two fractions have to have the same denominator. And so we may have to do some additional work to make that happen. So there's basically three things that could happen. Either I give you a problem where the denominators are already the same. I give you one where one denominator can just be multiplied by a factor to make them the same. Or the hardest case, where both fractions have to be changed in order to add their numerators. So case 1, right, just quick reminders of what we know from earlier math classes. If you already have the same denominator, we're just counting how many slices of pizza. You had 5 of the 12, you ate one of them, there's 4 out of the 12 of them left, or 1/3 if you reduce it. Same thing, if you have 7 of the 15 puzzle pieces and I have 3, together we have 10 out of the 15 pieces. So notice here the denominator stays the same and we just add the numerator. You can have fractions added and subtracted that require a little more work. So let's say we wanted to add 3/5, or we wanted to do 3/5 minus 7/15. Well, we would first need to turn that denominator 5 into a 15. And the easiest way to do that is to multiply by 3/3. We are allowed to do that because 3 divided by 3 is 1. We're just multiplying by 1, and that doesn't change the fraction. So what we have here is 9/15 minus 7/15 to give us a final answer of 2/15. So again, that was the case where we changed one fraction to match denominators with the second. The third case is one where we actually have to change both of these fractions because 12 can't be multiplied by anything to make 15. Now, one way to do this would just be to multiply the left by 15/15 and the right by 12/12. But you can save yourself a little time if you realize, let's break this up. This is 5/4 times 3, and this is 4/3 times 5. So they both already share a factor of 3 in their denominator. We just need to multiply the right fraction by the 4 that its denominator is missing, and the left fraction and the left fraction by the 5 that its denominator is missing. So what we'll have here when we multiply the left two together, 5 times 5 is 25 over 5 times 4 is 20 times 3 is 60. So we have 25 over 60 plus 4 times 4 is 16 over 3 times 5 is 15 times 4 is 60. So see, we could make these both out of 60, and that would give us 41 out of 60. Now again, if you didn't want to factor it, you could just multiply the left by 15/15, the right by 12/12. It would reduce to make 41/60. And we're going to have the same exact three cases that are going to happen when we add and subtract rational expressions, fractions. So case 1, the case that takes about 3 seconds to do, if you already have the same denominator here, we could add these together. So we would just have 2x squared plus 5x minus 3 over x squared minus 9. Now sometimes, if I want your answer in simplest factored form, Before, there was nothing to factor up top, but now we have a trinomial that can be factored. So we can factor this top trinomial. I know it's going to need to be 2x and x, and the way that I'll get a plus 5x in the middle is if I make this the plus 3 to make 6x, and this the minus 1. So that is how you would factor 2x squared plus 5x minus 3, and x squared plus 9, x squared minus 9 is the difference of squares. So we would be able to divide those together to make 1. Our final answer here would be 2x minus 1 over x minus 3. So there's some factoring and simplifying that goes on here, but the important part was that these already had the same denominator. Seeing it one more time, if we added these, or subtracted these now, 2x plus 3 and x plus 1. One of the really important things to remember here, and if you want to do this on a separate line, that's fine, is that this minus sign will apply to everything in that second denominator. So that minus sign gets applied to both places. You can either just like read it straight through, or you can just take a second, 2x plus 3, and just distribute it out, minus x minus 1. So 2x minus x gives us x, and 3 minus 1 gives us 2. So this will be x plus 2. So we'll have x plus 2 over x squared minus 4. Once again, I see the difference of squares on the bottom. This is x plus 2 times x minus 2. So I'll cancel those. And again, canceling, this is why I really should stop using the word canceling. What canceling is it's saying, oh, x plus 2 divided by x plus 2, that is 1. So we have a 1 left on top divided by x minus 2. It doesn't just go away. A common mistake here is people just think the answer is x minus 2. It's 1 over x minus 2. Okay, we'll do one of each of the following examples. So we've got cases, yeah, this will be good here. We'll just do a couple of these here. If we do not yet have the same denominator, we need to make that so. And so in order to see what is the easiest way to do this, I need to factor. I don't just want to multiply the left and the right by each other's denominators. What I want to do here is I want to factor this into x plus 4 times x plus 2. And so if I factor that out, what I can see is both of my fractions already have the x plus 4 in their denominator. I just need to multiply the left fraction by x plus 2 over x plus 2. And so what that leaves me with is 5x plus 10, that's this 5 times that x plus 2, over x plus 2 times x plus 4, plus, now we've got 2x minus 2. Nothing changed about this, because remember, all I did was 2 minus 2x. All I did was factor that denominator. Nothing changed there, x plus 2 times x plus 4. So now we can add these together. We'd have 5x and negative 2x make 3x. 2 and 10 make 12, so we'd have 3x plus 12 over x plus 2 times x plus 4. However, 3x plus 12 can be factored as 3 times x plus 4. And so what that's going to do is that's going to cancel the x plus 4. Those will divide to make 1. So I'll have 3 times 1 is 3 over x plus 2 times 1 is x plus 2. 3 over x plus 2, final answer. All right, we're at about 9 minutes here, so I just want to see how can I do this really. Let me find the best one that's left. This would be a good one. We'll do this one, and that should get you enough ready to do your delta math here today. I'll do the rest of these out, and I'll upload this so you can still see all of the examples here. If we have 3 over x plus 1 plus x over x minus 1, there is nothing that these have in common, because these are entire factors like this. So there is no easy way to do this. You just need to multiply the left by x minus 1 over x minus 1, and the right by x plus 1 over x plus 1. And so when we do that, what we're going to have here, when we do this out, we're going to have 3 times x minus 1 over x plus 1 times x minus 1 plus x times x plus 1 over x plus 1 times x minus 1. So notice they each now have the same denominator. The left had to get multiplied by what it was missing. The right had to get multiplied by what it was missing. So we do this out. We have 3x minus 3 plus x squared plus x all over x plus 1 times x minus 1. What we're going to have here is this will be equal to x squared plus 4x minus 3 over x plus 1 times x minus 1. And there is nothing to factor there because there's no this here, x squared plus 4x minus 3. That cannot be factored. So you are good to go. This is your final answer here. So the Delta Math problems will be working you through similar exercises today.